Hello everyone, welcome back to my channel. Today, we're diving into a fascinating topic, soil phase relationship. Have you ever wondered what's really inside the soil beneath your feet? Soil is a combination of different components that work together. Let us explore the relationship of these components and why this matters in geotechnical engineering. To visualize soil phase relationships, we use a phase diagram. This diagram represents the three main components of soil. Solids are the mineral particles and organic matter that form the skeleton of the soil. Water is the moisture present in the soil void between the solid particles. And air is any void space not occupied by water. Depending on environmental conditions, soil can be dry when voids are filled with air, partially saturated when voids are filled with both air and water, or fully saturated when the voids are completely filled with water. Together, these three components define the physical properties of soil and how it behaves under different conditions. So why do we care about soil phase relationships? Well, in civil engineering, soil strength, compressibility, and permeability depend on the proportions of solids, water, and air. This is crucial for designing foundations, roads, and embankments. To quantify soil phase relationships, we use important parameters such as void ratio, porosity, degree of saturation, water content, and soil unit weight. Now, let's break down this essential soil properties and their formulas used to analyze soil phase relationships. Void ratio is the ratio of the volume of void space to the volume of solids. A higher void ratio means the soil is more porous and looser, while a lower void ratio means it's denser and compacted, which is key for construction projects. Porosity is the percentage of void space to the total soil volume. Clays have low porosity as its tiny particles pack tightly, while sand has high porosity due to larger particles creating more voids. Degree of saturation is a percentage of the volume of water to the volume of voids. Degree of saturation is 1 in fully saturated soils and 0 in dry soils. Water content is the ratio of the weight of water to the weight of soil solids. Specific gravity of soil is the ratio of the unit weight or density of soil solids to the unit weight or density of water. Unit weight is the most important parameter used to determine soil stability, load-bearing capacity, and compaction in construction projects. It can be bulk unit weight, dry unit weight, saturated unit weight, and submerged unit weight. Bulk unit weight is the weight of soil per unit volume, including air, water, and solids. It's used in earthworks and foundation design. Dry unit weight tells us how compact the soil is when there's no water. It's a crucial parameter for compaction control in road construction. Saturated unit weight is the unit weight of completely saturated soil. It's important in flood control and underwater construction. Submerged or buoyant unit weight is the difference between the saturated unit weight and the unit weight of water. It is important when foundations underwater experiences buoyant force. These soil properties and unit weights are used in design and construction of roads, dams, foundations, and flood management. As a bonus, the following equation shows the relationship between these important parameters. And that's a wrap on soil phase relationships. If you found this video helpful, don't forget to like, share, and subscribe for more engineering and geotechnical insights.